Hi everyone, this video is an exercise 11, the question 2, and in this video I'm going to do parts C and D. So in part C we want to integrate sine 5 3x times cos 3x. Okay, so in this case, which is obviously a reverse chain rule, um, so the way that we can understand its reverse chain rule is when we see that we have sort of two functions and one of them looks like the derivative of the other one. So in this case, we have sine 3x and cos 3x. So cos is essentially the derivative of sine. So the educated guess is always with the function that has, or at least most of the times, has the highest power. So in this case, we are going to guess that when we integrate, we'll get sine to the power of 6 3x and plus c. Okay, now let's basically differentiate this and see what's the derivative. So we have 6 times, so from inside we have 3x, so 3 differentiates, and then sine itself differentiates to cos, so we have cos 3x outside, and then inside is basically sine 3x, but then the outside power is obviously 5 because 6 minus 1 is 5. So this is the derivative, which is essentially almost the same as here. So as you can see, the bracket term is the same as sine to the power of 5 3x, and then we have cos 3x. So here, this is the additional constant that we don't want to have. So we have 18. So we must have 1 over 18 so that they cancel out. So that means there must be 1 over 18 here. So this is basically the derivative. Sorry, when we integrate, that's the answer. Okay, now we have cos x times e to the power of sine x. Now in this case, again, this one might look complicated, and especially if you learn in one of the future sections, we have a technique called integration by parts, and this can be tempting that to use integration by parts, but this is actually much simpler than that and much quicker because again, this is about just identifying the different properties. So in this case, we have e to the sine x. So first of all, when we integrate e to the power of something, it's always that we differentiate the power, and that the reciprocal of that becomes the coefficient of e, and then the answer is basically 1 over that derivative times e to the its power. So in this case, what I'm trying to say is that when we differentiate sine x, we'll get cos x. So let's make the educated guess of for the answer to the integration be e to the sine x. Now let's differentiate this. So sine, as I said, differentiates to cos, and in this case we have cos x e to the sine x, and that's it. So as you can see, this is actually a very quick one. So this is one of those cases. I think this is the first case that we actually didn't need to make any adjustments, and our educated guess was 100% correct. So this is not normally the case. We normally make some adjustments, but yeah, here just e to the sine x plus c. So that's the answer.